For years, astronomers have been captivated by Betelgeuse, one of the brightest and most mysterious stars in our night sky. This red supergiant has been teetering on the edge of collapse, and scientists knew its end was coming. They just didn't know when.
Betelgeuse is a massive star, maybe 15 or 20 times the mass of our sun, and it's near the end of its life.
It is a massive, enormous, luminous star, and one day, gonna go boom.
But now, the James Webb Space Telescope has captured something truly historic, something no one was sure we'd ever witness. The very moment Betelgeuse began to explode. We're talking about a stellar death, a cosmic shockwave, and an unparalleled window into the raw, untamed power of the universe. This isn't just another deep space observation. This is a once-in-a-lifetime event, the closest supernova humanity has ever recorded. And what the Webb telescope has seen? It has changed everything. Betelgeuse, located in the shoulder of the Orion constellation, is no ordinary star. It's a colossal red supergiant, over 700 times the size of our sun and roughly 20 times as massive. For decades, scientists have understood its unstable nature, constantly swelling, dimming, and erupting. Back in 2019, Betelgeuse suddenly faded, triggering a wave of global speculation. Was this it? Was the cosmic giant finally going supernova? Now, with the precision of the Webb telescope, the mystery has only deepened. For the very first time, we are seeing real-time indicators of a star in its final throes. Massive energy, discharges, a wildly shifting surface convection and magnetic fields twisting into utter chaos. Betelgeuse isn't just dying, it's transforming right before our very eyes. The James Webb Space Telescope has been laser-focused on Betelgeuse for months, using its powerful infrared vision to peer into layers of the star invisible to any previous observatory. And now the data is in, and it's stunning. We can see convective bubbles the size of Jupiter bursting on Betelgeuse's surface. We can trace vast plumes of hot gas streaming into space at unimaginable speeds. And hidden within the light spectrum, Webb has detected a signature shockwave moving through the star's outer layers. This is groundbreaking. For the first time, ever, astronomers are observing the actual physics of a star tearing itself apart. This isn't a simulation. It's the real-time anatomy of a supernova, happening just 642 light-years from Earth. Unlike other supernovae that occur in distant, far-away galaxies, Betelgeuse is, cosmically speaking, right next door. Its eventual explosion will be so bright it could be visible during the day, outshining even the full moon. But more importantly, its proximity gives scientists a once-in-a-generation opportunity to study the death of a star up close. We can observe how its core collapses, how essential elements like carbon and oxygen are forged in its death throes, and how the resulting shockwave reshapes the surrounding space. What Webb captured isn't just a star dying. It's the very process that creates the ingredients for life, the same elements that formed Earth and, indeed, us. We are, in a way, watching our cosmic ancestry unfold in reverse. The Betelgeuse explosion is far more than a breathtaking spectacle. It's a key, unlocking the hidden processes behind galaxy formation, the development of planetary systems, and the fundamental cycle of life in the universe. Thanks to Webb's advanced instruments, we can now model the final stages of stellar evolution with unmatched precision. We can finally gain a true understanding of what happens inside a star as it dies. And excitingly, we may even learn what signals to look for in other stars, possibly allowing us to predict future supernovae long before they happen. This isn't just science. It's a revelation, a moment where humanity has looked into the abyss of time and witnessed the light explode. Ripples through space and time. The explosion of Betelgeuse is not an isolated event. It sends powerful shockwaves across light years, profoundly disturbing the surrounding interstellar medium. Webb has already detected the early ripples, high-energy particles moving outward, heating nearby gas clouds, and altering the shape of the star's existing dust halo. But there's something else, something even more profound, a potential gravitational shift. Even from 642 light-years away, the collapse of Betelgeuse's core may have sent out gravitational waves, the elusive cosmic ripples we've only recently begun to detect. If confirmed, this would mark the first time we've directly linked a visible supernova with gravitational wave data. Such a discovery would rewrite everything we know about the fundamental interaction between light, matter, and space-time itself. What remains? A cosmic question. As Betelgeuse collapses, one of the greatest cosmic questions re-emerges. What will be left behind? A super-dense neutron star? A mysterious black hole? Or perhaps something even stranger? The data from Webb suggests that Betelgeuse's collapse may not be entirely uniform. Scientists are observing magnetic field disruptions, intriguing plasma voids, and a possible asymmetric fallback, where some material doesn't escape into space, but is instead drawn back inward. Some astrophysicists are even speculating about the formation of a transitional object, a theoretical phenomenon that sits somewhere between a neutron star and a black hole, something hypothesized but never before observed. If Webb has indeed caught this in action, it would be the first direct evidence of an entirely new class of cosmic object. Are we in danger? With the star exploding just 642 light-years away, many have understandably asked, are we in danger? The short answer is no. Betelgeuse isn't close enough to directly harm Earth. However, the longer answer is more complex. The explosion will release a massive wave of high-energy particles, gamma radiation, and expanding electromagnetic bursts. While not catastrophic for us, these could potentially disrupt cosmic dust clouds, influence other star systems in our galactic neighborhood, and even trigger changes in how light from more distant regions reaches us. For now, Webb is closely monitoring the velocity and spread of this radiation front, because even if we're safe, the Betelgeuse explosion may subtly alter the optical structure of our cosmic environment, changing how we observe the universe from this point forward. The cosmic mirror and renewal Betelgeuse is massive, ancient, and incredibly powerful, and yet it's dying. A profound reminder that even stars, those seemingly eternal lights in our sky, have limits. What Webb has captured isn't just the death of a star. It's a cosmic mirror held up to us. Everything that lives eventually ends, but in that end, new elements are born. New stars will rise from Betelgeuse's ashes, and new worlds may eventually form in the chaos it leaves behind. This isn't simply destruction. This is cosmic renewal on the grandest scale, and we were incredibly lucky enough to witness it. An unexpected chemical signature. Among the vast trove of data collected by the James Webb Space Telescope, scientists discovered something truly unexpected: significant variations in the elemental composition of the material ejected by Betelgeuse. The explosion is releasing not just common elements like carbon, oxygen, and iron, but also rare elements, such as technetium and yttrium, which are formed only in the most extreme stellar environments. Why is this significant? Because analyzing the ratios of these elements allows scientists to trace the complete life cycle of matter in our galaxy, from the fiery core of dying stars to the dust that eventually forms planets, right down to the very atoms inside you and me. Webb isn't just recording an explosion, it's decoding the chemical script of how life itself becomes possible. And Betelgeuse, in its final, spectacular moments, is telling a story that began long before Earth even existed. Betelgeuse is lasting. Gift Betelgeuse, as we knew it, will never return. Its place in the constellation Orion will gradually transform into an expanding cloud of superheated gas and glowing debris. But its death isn't an end. It's a gift. A gift of knowledge, a gift of essential elements, and a gift of profound perspective. It reminds us that our own sun too will one day fade, that even the most brilliant lights in the sky have a final act. And yet, from this ending comes the blueprint for everything new. Because without supernovae like Betelgeuse, there would be no planets, no oceans, no life. And now, thanks to the James Webb Space Telescope, we can finally witness that full, incredible cycle, from fiery collapse to the raw materials of creation. Echoes of creation, glimmers of the future. In the cold silence of space, 642 light-years from Earth, a star has ended its life, not with a whisper, but with a brilliant final roar that traveled through the darkness for centuries until it finally reached us. Thanks to the James Webb Space Telescope, we didn't just see it, we understood it. We saw the signs, the collapse, the detonation, not as myth, not as metaphor, but as undeniable fact. Betelgeuse didn't die in vain. In its final moments, it gave us answers to questions older than humanity itself. Where do the elements come from? How do stars truly live and die? And what will eventually happen to our own sun? In that fading red light, Webb has captured more than just a supernova. It captured our origin story and offered us a profound glimpse of our cosmic future. So now, we ask you, what else is the universe ready to show us? And are we, as humanity, truly prepared to witness it? Let us know what you think in the comments below. Was the Betelgeuse event the most important stellar observation of our time? And what cosmic secret do you think the James Webb Telescope will reveal next? Don't forget to subscribe and turn on notifications, because this isn't the end. It's just the beginning of understanding what comes after the stars.